Hey, geometry. Today we're going to do lesson 4.2, isosceles and equilateral triangles. You can follow along in your book on page 157, and it has all the theorems there too, so you can write them as I'm talking. So our first theorem is 4.1. It's called the isosceles triangle theorem, and they're giving you a bonus, 2 for 1. You have 2 theorems in one, because we're going to do the converse also. We're going to consider it the same theorem. So it says, if 2 sides of a triangle are congruent, so here we go, then the angles opposite those sides are congruent. So if I have that triangle, then I have these two angles are congruent. You can see that kind of makes sense. It just looks right. And then your bonus is, if you have 2 angles congruent, then you have 2 opposite sides are congruent. So we have a theorem going this way and a theorem going this way, which means you just write it is like this, right? Double arrow going both ways, or we can write it as this. If and only if, that works. So if you're super lazy, all you would write was this for your theorem. Or maybe if you had a note card for a test, which of course doesn't happen because we're all online. And so we don't have note cards. We don't have tests. It's terrible. You can just use your whole book. Here's just a fun example that we can do. And this is really just to practice your algebra. And I was kind of thinking of, why would you ever need to do a problem like this? We have some made up problem that they probably just picked because the numbers work out. We say, oh, well, I know these 2 angles are equal. So that means these 2 sides must be equal. And we just say x plus 20 equals 8x over 3 by theorem 4.1. And then, of course, I'm going to just do 3x plus 60 equals 8x, 5x equals 60, and x equals 12. And then I say, well, if x equals 12, then this side equals 32. This side equals, 12 divided by 3 is 4. Oh, look at that. This side equals 32. It better, right? And then I have 6 times 12 minus 12, which is really 5 times 12, which is 72. That's my favorite number. Done. Thought it was easy. All right, let's do this one. And if it was not easy for you, then you can slow down and do it again because this is on a video. All right, theorem 4.2. If a line or segment bisects the vertex angle of an isosceles triangle. All right, let's get that in an image. I have an isosceles triangle. That looks equilateral. Let's not do that. There. I have an isosceles triangle. And if I have a line or segment that bisects the vertex angle, so that means I'm drawing a line here or constructing it. These are the same. It is also the perpendicular bisector of the opposite side. So that means if I have this triangle and I drew this line right here, it also means that this is perpendicular and that these are the same length. That's your theorem 4.2. And both of these theorems want you to prove these by transformations. And I'm going to skip that for now. And it's just like a personal bias of mine. I don't want to do that. So I hope you can do that. I'd love it if you did it and taught me how to do it, but I'm not interested in it. So sorry. Okay. And then here's another concept. This, is probably an equilateral triangle. We say equilateral. Lat means like, I think sides. Equal means equal, right? So, or length, probably lat is length. Latitude, what's another lat word? We could also call this angle, with this triangle that has the 3 angles, equal, I'm like, must be at, angular, like angles. So if I say draw an equal angular triangle, you would be drawing an equilateral triangle and vice versa. And there you could prove that if you had an equal angular triangle, try that for a tongue twister. It's also equilateral. Because look here, an equiangular triangle is also an isosceles triangle because you have this. And so then if you bisected this side right here, what would happen? Oh, sorry. You don't have to even bisect it. If I have two of these sides are the same, then I have these are the same. But I also know these two sides are the same. So that means those two are the same. That's what we got. That took a second. All right. These are pretty simple concepts. You can just tell pretty much by looking at them. So let's just do one more problem. This is a try it in your workbook, and I encourage you to go through your workbook and just go through the problems. They're pretty simple. Page 84, and this is in your book too. So they give you this triangle, and they say, what is measure of angle RSQ? So let's first figure out which one is RSQ. That is RSQ. Okay. Well, we're going to figure out that angle. Well, all I know is that, this is equilateral, then these two angles have to be the same. Okay. And if, and this angle, sorry, is marked as the same as this angle in the book. Sorry, I didn't catch that. Phew, because if that is an angle bisector, that means these are the same. And if those are the same, then this is a perpendicular bisector because of this. And so if this is 31, then this has to be 90. So this has to be 90 minus 31, which is 60 minus 1 is 59. We got it, 59 degrees. Okay, and then I have PR. Well, let's see, I have PQ and I have QR, but I think PR is all of this, and it must be double this because these two are the same length. There we go. See, they're fun. So you see that, like, you know one angle and one side and you're done. Now it's going to be even more fun when we learn trig and you know less, and it's not equiangular, and you get to use all these kind of proportions for triangles. That'll be more fun. Anyway, have fun with these problems. I think you'll enjoy them.